All right, 22 through 33. We need to fill in the chart below. This is more of a process type problem instead of an instant recall type problem. All we need to know are the protons, the electrons, and the neutrons. All right? And if we really pay attention to what the periodic table tells us, this isn't too difficult. So let me open up the internet and find the periodic table. Great. That'll open soon. Let's pause here. All right, that was a lot bigger pain than I thought. But we're back. All right, so what I did, I went online, I just typed in a periodic table, and here we go. So if you'll look with me, I don't remember why, but for some reason when I'm doing this program, I can't draw on it. But if you look at iron, everyone look at iron for me. Iron is Fe. There are two numbers. There's 26, and then the bottom there's 55.845. I want you to round that number, and on your periodic table, if you have that with you, it'd be even better. Iron is 26 and 56. All right, so let's go back, and now let's just write this real quick. So we had this box. We had Fe. Then we had 26 and 56. Now, sometimes 56 is on the bottom. I think it probably was. It was on that table. Sometimes 56 is on the top. It doesn't matter which way we put it. All right, we can learn a lot of information from these two numbers. Make sure, like 100%, that you understand how to use this information. The bottom number gives us important clues. The bottom number tells us the number of protons. Okay? It will also tell us the number of electrons. Now we're going to learn later. I'm not even going to say it. We'll learn something else later that violates that, but don't worry about it. For right now, that works. So if someone said how many protons are in iron, I would say, oh hey, the bottom number, or the smaller number, I should say, is 26. That's easy. If it asks for electrons, I would do the same thing. For Fe, I look at it, I'm just like, hey, the smaller number is 26, so there must be 26 electrons. All right, so the bottom number will give us those two values. All right. Now, by the way, the protons for an element will never, ever, ever change. If you change the protons, you change what element you're talking about completely. So if I say 27, I'm not even talking about iron anymore. I'm talking about element number 27, which would be cobalt, right here in the middle. The top, or the small number, I keep saying it wrong, the smaller of the two values is the protons and never changes. All right, I'm going to run out of time here. The top number gives me information as well. The top number is the atomic mass. So if I just asked you, all right, what's the atomic mass of iron? You would just say 56. All right, but the atomic mass is found by taking protons and adding the neutrons. If you remember, I keep going back to a million things here. If you remember our neutrons, we said right here, the neutrons have a relative mass of 1 gram. All right, so they have a mass of 1, but we also said that about protons. Let's see if I can find that. Right there, they also have a relative mass of 1 gram. So we have to count for both when we find the mass. All right, this can be useful because if protons plus neutrons equals 56, and I know the protons is 26, so 26 plus what equals 56? Wife? 30. Good answer. So if I ask for neutrons, it equals 30. I'm out of time.